Hey guys, welcome to Unit 13, Lesson 2, Graphing Polar Coordinates. So please pause the video and try the warm-up. So the warm-up says, in which quadrant do each of the following angles terminate? I actually have sketched this quadrant for you with the quadrantal angles and the quadrant numbers also. We go in counterclockwise direction. Our angles are always positive, so that would be this direction. If we're going in clockwise direction, then my angle is negative. Okay, so this is something you know, we've talked about it in the past. For most part, polar coordinates, your angles are always given to you in radians. I would highly recommend start working in radians. If you still are confused with, then you must substitute pi with 180 to convert it into degrees, and that will give you your angle in degrees. But if you are going for your AP class of next year, I highly recommend working with angles in radians. So it's asking us for where these angles end up, right? I already wrote it here, 2 pi over 3. 2 pi over 3 is actually 120 degrees. How do I know? So substitute pi with 180 and divide by 3. 3 goes into 180 60 times. 2 times 60 is 120 degrees. So 120 degrees is between 90 and 180. So it's the second quadrant. If you were to sketch it, your initial ray is always glued to the x-axis. Your terminal ray would be here, right? And your reference angle is what? This is your reference angle. Your actual angle is this 120 degrees. So these are a few things that we've talked about in the past, but I just quickly wanted to review them. Theta equals pi over 4. Pi is 180 divided by 4, which is 45 degrees, which is in the first quadrant. Right? Oops. First quadrant. 5 pi over 4. Again, this is pi over 4 we just discovered was what? 45 degrees. If you want to do the mental math, you can do 45 times 5 is 225. So that's 225. Or substitute pi with 180. 4 goes into 180 45 times. 5 times 45 is 225 degrees. And 225 degrees is in the third quadrant. So this angle theta is in the third quadrant. Now when we have a negative angle, remember I told you negative means we're going in clockwise direction. So this is 180 divided by 6 is what? 60? 180 divided by 6 is 30, not 60. So this is negative 30 degrees. So if it's negative 30 degrees, we are in the fourth quadrant. Okay, so now polar coordinates. What are polar coordinates? So let's read about it and then I'll explain. A polar coordinate system has the traditional x and y axis, which you see them here. That's your y axis and that's your x axis, right? Where the intersection of these axes, the old origin is now called the pole. This is called your pole, okay? And then each point on the plane can be assigned polar coordinates r, comma, theta. So remember, alphabetically r comes first, so r, comma, theta. Theta is t. Theta is basically your angles and r is basically how far out are you from the pole. So let's say if it's at 1, then you would be here, 2 is here, 3, 4, 5. Okay, so you're going from the pole, not outside and inside out. So this is something some students get confused with, so I wanted to bring it out. Where r is, I'm sorry about this, just wanted to erase it. Okay, where r is the directed distance from the pole and theta is the directed angle. This is what we talked about. So here it's example 1. It's asking us to plot all these points. Oops. So before I even plot the points, I want to just convert them into degrees. So again, I'm going to show you the trick, which we've done it in class also. So this is 0 degrees. Pi is what? Half of 0 is what? 180. So this is going to be 180 degrees. Now, when you're working with these angles in the first quadrant, all these 4, I would say 4 angles in here, you're basically going to refer them in regard to 180. So it's 180 divided by 6 is what? 30. So this is 30 degrees. Then 180 divided by 4 is 45 degrees. And 180 divided by 3 is what? 60 degrees, so pi over 3 is 60. 180 divided by 2 is what? 90. What color we didn't use? We didn't use yellow. This is 90 degrees. Okay, so once you know that the rest of these remaining angles are actually multiples of these four numbers, and you'll see it. So let's look at the pi over 6 family, which is 30. Look at this here. Isn't this pi over 6? So this 5 times pi over 6, which is 5 times 30, is 150. 7 times 30 is 210. And 11 times 30 is 330 degrees. So look here. We already got those angles. Now we're going to talk about the pi over 4 family. That's 45. So this is pi over 4. 3 times 45 is 135 degrees. Then 5 times 45 is 225 degrees. 7 times 45 is 315 degrees. How did I know these are all pi over 4 families? I'm going to circle them so you understand that. Now we have the pi over 3 family, which is here, here, and here. So 2 times 60 is 120. 4 times 60 is 240. 5 times 60 is 300. So that's one way of doing it, rather than substituting in with pi, canceling it out. It takes a lot of time, and that way you will be able to memorize the angles and the radians and go back and forth. And now we're left with the last thing is 90. I could have done this as actually, these are the quadrants go by increments of 90. So that's why this is pi, because pi over 2, right, times 2 would be just pi. Pi over 2, which is 90, times 3 is 270. So this is 3 pi over 2 and 270 degrees. Okay, so this is how you label them. I would say keep practicing. There are a lot of questions on the next page. You have graphs with each question. Go blind on the previous question and write out your angles convert your radians to degrees and degrees to radians wherever you can, and that is the best way of knowing these questions or getting the conversions right. Okay, so now let's get started with the questions. So it's asking us to graph these points or plot these points. 4 comma pi over 4. So this is R. I'm going to take a darker color. This is R, and that's your theta. How do you start? Always the first thing is to look for your angle, and the second thing is you look for your R, right? Your R is basically your directed distance from the pole. Okay, so you're going to go outwards. Okay, so, and again, if your angle is positive, means you're going counterclockwise. Angle is negative, you're going, so I'm going to write here positive angle counterclockwise, negative angle clockwise. Okay, we need to know that. Now similarly, R also, if R is positive, we're going in that direction wherever the angle is. Negative R means the opposite direction, and we'll talk about it when we do the question. Just want to write that out. So let's first do the 4 comma pi over 4. You already know where pi over 4 is, but I'm going to just change it to degrees in case we want to understand that if we are still confused with radians. Okay, so that's how do we do this? Always start with your angle first. So your 45 degrees or pi over 4 is on this segment, right, somewhere here. How do I know where that point lies? You're going to go 4 points or 4 places from the pole. So I'm going to erase this, and it's going to be 1, 2, 3, 4. So this is 4 here. So that's your point P. Now the next one is 7 pi over 6, which is 210. So 2 comma 7 pi over 6. So I'm going to change the color. 7 pi over 6 is here, right? And 2 means outside 2, so I am going to place my 2 here. 1, 2. So that is your point Q. Now 5 comma negative pi over 3. So 5 comma negative pi over 3 means negative 60, right? So negative 60 means I'm going in clockwise direction. So negative 60 is same thing as 300 or negative pi over 3. I'm going to write that out. So now I am 5, my R is 5, so it's going to be 1, 2, 3, 4, 5. So that is my point. So D. So D here, be very careful now. Let's do this again. So let's first convert it into degrees. 3 pi over 4 is 135 degrees. The only thing this 2, my R is negative means what? I'm going to be in the opposite direction of 135 degrees. So wherever my 135 is, what is opposite of 135? It will be something. 135 is in the second quadrant. So something in the fourth quadrant. That's where my point will end up. That's what basically it means. So how do I determine that? There are multiple ways again of doing it. I like to actually, this is my angle 135. I'm going to use my highlighter and highlight this line 135. And the opposite would be what? 7 pi over 4 or 315. If in doubt, look at the reference angle. They both should have the same reference angle. They both have the same reference angle of 45 degrees. I basically went what? 180 degrees in the opposite direction, right? So the negative 2 would be, I'm going to take a different color. So now I'm going to be on this segment, 1, 2 out. So that is my point. Yes, that's it. There's nothing more to explain. So basically I can say negative 2 comma 135 can be written as 2 comma 315 degrees too. This is the same thing. So these points are not unique. They can be written many different ways. Okay, the same point can be written multiple ways. Okay, I want to do one more with you. It's not given to you in your packet, so that's why I wrote part E here. T equals negative 5 comma 11 pi over 6. So again, 11 pi over 6 and my R is negative means I am going to be going opposite of 11 pi over 6. So what is opposite of 11 pi over 6? It is, again, either sketch it, trace it, just take your pencil, pen, whatever you're using, and go in the opposite direction. If in doubt, look at this. The angle here is 30 degrees. The reference angle, and here also it is 30 degrees, so you're good. Now it's negative 5, so I'm going to go 5 out. 1, 2, 3, 4, 5. So that is where my point T is. That's it. There's nothing more to it. It's just the opposite direction of R. So I can rewrite T as negative 5 comma 330 as, which was the conversion. I said it verbally, but I didn't write it out. Is the same thing as writing 5 comma 150, right? So these are 2 ways. We're going to learn another 2 ways of writing it out. Think about it. What would be the other 2 ways, which would be in the next question. So each polar coordinate pair determines a unique point. However, the polar coordinates of a P in the plane are not unique. The coordinates, because we can write those coordinates multiple ways. We just saw it how we could write that one coordinate 2 different ways. Actually, we can write it 3 or 4 different ways. So if the point P has the polar coordinates 4 comma pi over 4, find the 3 additional pairs of polar coordinates for P. So my angle is 4 comma 45 degrees. Pi over 4 is 45, right? You can go around and label your angles in degrees. I'm going to just label this. This is 45 degrees, and across from it is what? 5 pi over 4, which is 225 degrees. But also these are if I go in counterclockwise direction. What if I go in clockwise direction? Isn't 45 degrees same thing as negative 315 degrees? Similarly, 225 is same thing as negative 135 degrees, or I would say negative 3 pi over 4, and this is negative 7 pi over 4. Right, so I just wanted to write out the angles in radians for all those negative angles also. Okay, so why do we need this? Because it's asking us for 3 additional points. First, let's plot this given point. So it's pi over 4, which means I went pi over 4 in counterclockwise direction, and my directed segments 4 out from the pole. 1, 2, 3, 4. So that is my point P. Label it. Always label them. Please don't make mistakes of not labeling them. Now, what are the multiple ways? Do you agree? This was when we went in counterclockwise, right? My 45. But if I went in clockwise direction around and I would end up at the same point, so means my other point could be rewritten, this point can be rewritten as 4 comma negative 315 degrees. I'm going to write it in radians also. 4 comma negative 7 pi over 4. That's one way of writing it. It's at 3 ways. The second, what if I go in the opposite direction, right? If my r is negative, do you agree if I had the negative r, I'm going to highlight this in blue. So if my r was negative, I'm going to go in the opposite direction, right? And that would be what? It means negative 4 comma 5, I'm doing angles first in degrees, 225 degrees, which is same thing as negative 4 comma 5 pi over 4. And number 3 is 5 pi over 4 is if I'm going in counterclockwise direction. If I went in clockwise direction, it'll be negative 4 comma, we already wrote it, it was negative 135 degrees, which is same thing as negative 4 comma negative 3 pi over 4. So these are how you write out multiple ways or additional ways of the same polar coordinate. So if I was to sum up and give you the formula for these to get this, basically what did we do? It was whatever your r was, r comma theta plus and minus 2 pi or 360 degrees. And the other one, to get the other two, what did I do? Negative r, so that's why I went the opposite direction, but this was what, 180 degrees, right? So theta plus and minus 180 degrees. So these are your formulas. I don't see the need of the formulas because then it's just like memorizing it. Just apply your logic, stretch that line segment all the way across, and you'll know your 4 angles. Go in clockwise direction and counterclockwise and account for everything. So it says, what about the point Q 2 comma 7 pi over 6? So again, convert it into degrees. So it's 2 comma 210 degrees. If you feel comfortable converting working in radians, please go for it. So that's 210 degrees. And I'm going to write this was my counterclockwise angle. My clockwise angle would be same thing as negative 150 degrees, right? So that would give you your 2 points. So 7 pi over 6 or 210, and your r is 2, means you're going to go out 2 from the pole, 1, 2. So that is where your point is, Q. And what would be the 2 representations? This is given to you. I'm going to write 2 comma negative 150. Let's convert it into radians also, negative 5 pi over 6. Now I want to go in the opposite direction when my r is negative. So where would I end up? Let's do this. 7 pi over 6 will correspond to pi over 6, which is 30 degrees. This is 30 degrees if I go in counterclockwise direction, and negative 330 if I go in clockwise direction, right? We're all good with that. If in doubt, let me just explain. This is counterclockwise. That's how I got 30 degrees. I did 30 minus 360, so I went all the way around here. So that is negative 330. So we'll end up in the same place. Okay. So these are your 2 angles. That'll help you understand. So my second point would be, since I'm in the opposite direction, so my r is going to be negative, and my 2 angles are going to be what? One's 30, and then the third is negative 2, negative 330. Let's convert them into radians also. This is pi over 6, and this would be negative 11 pi over 6. So again, you could use the formula, or you could just graph them and just look at it in both clockwise and counterclockwise direction. Okay, so I want to do actually number 4 with you guys. because it has a radical 3, which is not hard, but for some reason I feel some people get confused with it. So the directions are the same. You're plotting each of the polar coordinates and then find 3 additional polar representations of the point from negative theta between negative 2 pi and 2 pi, meaning it's between negative 360 and 360 degrees. Okay, so again, you always start with your angle. I'm going to first of all convert it. It's rad 3, which is approximately 1.7, right? So 5 pi over 6 is 150 degrees. So I'm going to actually highlight 150 in this line segment. So this 150 degrees when you go in counterclockwise direction. The same angle can be rewritten as negative 210 if I go in clockwise direction. Do you agree? So my other angle would be, so first let's plot the point, rad 3. So 150, rad 3, it'll be more closer to 2. Because rad 4 is 2, so rad 3 is a little less than 2. If you didn't even know the exact number, if you didn't have the calculator on you, just use your educated guess. You know square root of 4 is 2, so square root of 3 would be something less than 2, but closer to 2. Okay, so that's your point, and there's no letter to it, so we're just going to mark that point. Now we want to write it 3 different ways. So what do? This is same thing as writing rad 3 comma negative 210 degrees, right? Now if I make my r negative, where would I end? What angle? It would be, if you're guessing 11 pi over 6 or 330 degrees, you are absolutely right? So it would be negative rad 3. Remember, the negative is outside the radical, and that's 330 degrees. 330 degrees. And still negative. This 330 is when we're going in counterclockwise direction. If I'm going in clockwise direction, what would that angle be? Wouldn't that be just 30 degrees, negative 30 degrees? So negative rad 3 comma negative 30 degrees. So these are your other 3 additional ways of labeling this point. So I'm going to convert them into radians also. It's going to be rad 3 comma negative 7 pi over 6, negative rad 3 comma 11 pi over 6, and negative rad 3 comma negative pi over 6. So that's your answer. So for each of these questions, you're graphing the point and then you're writing it 3 more ways. Okay.